Good morning, good afternoon, and welcome to a conversation on wireless connectivity in the enterprise. This is part of a report from Senza Fili and in collaboration with RCR Wireless. We talked to different companies and service providers to see what they see in the future of the enterprise. Today I'm talking to Asha Keddy, VP at Intel, and she's working on defining the path forward on 5G. Asha, thanks for being with us today.
Thank you. My pleasure.
Yes, so Asha, to get started, can you tell us a little bit more about what it is that you do at Intel these days?
Sure. At Intel, I run a team that's called Next Generation and Standards. And my main focus is to look at things that are around the corner, like, for example, a lot of what is 5G, the standardization work and the trials that go along with it, and also the business development among these new areas that enable new technologies, including 5G.
Okay, so let's get started and talk about the enterprise. There is a lot of interest for the enterprise, but what is changing there? As we move to 5G and before there with gigabit LTE, what's changing in the enterprise from a technology point of view?
So good question, Monica. I think I'd like to start with 5G a little bit. And as you know, 5G is all the things that we do to enable, as NGMN says, a fully connected, mobile, intelligent society. And I paused on each of these words because when you talk about a society that's fully mobile and intelligent and connected, what happens is that you need ambient compute and communications and other things all as a part of your business. You talk about enterprise. And so what happens is, whether it's my sister who's a housewife or an enterprise or a small business, you need to be able to access this fully connected mobile society to help be competitive. And what we can do with things in 5G in particular, by taking an end-to-end view, is we can start not only customizing the devices and the applications that the enterprise uses, but also we can start looking at how does the network work? How can we customize it to the mobile edge, right? And what can we do? For example, we have done some analysis, which are partners in research areas, which shows that you can customize things where you can have things cached on the mobile edge for that particular enterprise. With that, you can download things faster. You can have better customer service or better service within the enterprise, including B2B, because you're focusing on those particular applications.
Yeah, so there are multiple ways in which the enterprise is going to be affected. So the first one that you pointed out is the flexibility. Yes. And maybe you can talk a little bit about how do we achieve the flexibility, because from the enterprise point of view, there are specific needs. Every enterprise has their own needs. So flexibility is paramount in making sure that each enterprise gets what they need. So how is 5G going to help them in terms of, as you were mentioning, doing more stuff at the edge, or having more flexibility, customizing the network?
So two ways where we can, your question is really about flexibility and how can we help enterprises. So one of the things with 5G is, as you know, it's about billions of connected devices. And in a lot of these cases, the devices are talking to each other. We're moving away from where the majority of the connections are with the human and the computer, right? Like a PC or a phone. So with that in mind, if I look at an enterprise and I look at 5G, with 5G, what you notice is that the ITU has three different angles at which 5G is defined. One of it is evolution of mobile broadband, which is the things we know well, but how do we evolve it? For example, 8K videos, VR, entertainment and all. Another one is around ultra high speed and low latency. For example, what can we do to replace VR, remote surgery, autonomous driving, or in fact, even in factories or industrial automation, things that require extremely high precision and low latency. At the other extreme is the evolution of narrowband IoT, or towards massive machine type communications, which may be things around like maybe an industrial factory where a lot of things are operated by sensors, and how do you turn off and maintain all of these things together. So with 5G, you're actually designing a technology that not only is forward compatible from an air interface point of view, but we also are conditioning the network and having the network evolve to more of a software defined network, and having things where you can cache, such as the mobile edge, and the concept of mobile network slicing, where I can differentiate different types of traffic. As a enterprise, I can say these types of traffic are much more important than certain other kinds of traffic because they're more important to the quality or reliability or certain other things. So when you start taking the design of 5G, where you have these different use cases, combined with data and the network virtualization, you can start really customizing the solutions to your enterprise. Even within an enterprise, you might have different kinds of use cases that have different latency sensitivities or bandwidth sensitivities.
Yeah, so now let's talk, for instance, about both the edge computing and the slicing. Can you give us some example of maybe trials you've done or use cases that you've seen where the enterprise benefits or needs them to develop some services that they need?
Sure. So you're asking about like network slicing and quality of service related items?
Yeah, something, yeah.
I'll give you an example that we have been starting to model, and then how we can take it to the enterprise, right? One of the things that we have focused a lot of is on autonomous driving. And in autonomous driving, it's very important to differentiate. For example, if I'm going in a flooded area, or like right now we have a lot of wildfires here in Oregon. If I need things that go beyond like just autonomous driving, where connected car can start helping, to know what are some of the fire hazards or some of the floodplains and some of the safety things that are ahead around on my route. That kind of information can be very critical to planning and to not be stuck for hours. And we can differentiate those kind of traffic very differently from, let's say, downloading the next Game of Thrones or watching something like that. So we're starting to look at those, especially in a very mobile autonomous area. And now if you go to something that's more on a business edge, right? I can start looking at a particular type of transactions where I can look at how much I'm paying for a particular kind of transaction or the volume, and start customizing it. For example, if I'm a small business, then I might be able to have like loyal customers or some other customers, and know what they do and figure out, okay, this is something around a sale. How do I get those customers that are prioritized versus, something that is more generic.
Mm-hmm. Yeah, no, and that's very interesting. Another thing that there is a lot of talk about, it's the local breakout that edge computing allows. Do you see the enterprise being interested in that, and what is the value they see in that?
On the edge computing itself?
Yeah, on the local breakout that you can have with the edge computing.
So you bring up an interesting point. One of the things about the edge computing, and I'd also talk about venue-based services next, is by taking the computing at the edge, you're taking a lot of information down in the cloud towards the consumer or towards the enterprise in this case. So that allows for a few things. You get faster turnaround time because it is all at the edge. You don't have to take it all the way, but you also can customize what data goes to the cloud, right? There may be some privacy, some sensitivity issues. So in addition to being able to handle the data at the edge, right, as we look at the convergence, you can start adding things that are in particular to your enterprise. For example, if you are doing a venue-based service at a stadium, as an example, you can, once there's a touchdown, you can have it cached at the edge, because you know that after every touchdown, there'll be a lot of people downloading. There's also the inverse traffic happening. We see a big uptick on uplink communication, not just downlink. And so you can have all of these different models where based on the uplink, you can route it to a different part of the enterprise or the branch based on the decisions and the calculations you do at the edge.
Mm-hmm. Right, and this is sort of attest to the fact that the enterprise and locating venues as well, they have much more their requirements are much higher. So as we move to 5G, the network is going to be more powerful, but also the requirements are going to be more stringent. So, and it used to be that mostly what the enterprise did was some basic coverage, but now coverage is still essential, but not enough. You also need capacity and latency. Can you say something about how do these requirements are evolving in the enterprise?
So in enterprise, you're talking about coverage, capacity, and I think through when we talk about network slicing and all, we talk about quality of service. So right now where we are headed in is a world where every enterprise has to have an online component, right? It is a way of doing business. And then we are increasing a lot of the spectrum. So when you have different kinds of spectrum, unlicensed and licensed, and even like hybrid models, you are enabling different ways of how the enterprise can have access to it. So essentially, we're building more highways and different kinds of highways, if you will. So that's one aspect. Another aspect is on capacity. When you have things that are higher order spectrum and all, in the olden days, right, the base stations used to be these things used to go out in the field. They used to be waterproof, used to have to test the antenna, but we're flattening the network. And a lot of it is more general purpose. So we are reducing the cost of the CapEx, where you can use more off-the-shelf Xeon processors, for example, to do the computing. You're separating the radio heads from the software network, and we're having all these concepts like small cells, right? Mm-hmm. And so our density, where we spend a lot of the data consumption, is around stadiums, enterprises, and homes. So if you look at all of these areas, what we can do is do small cells that are very low cost, but very extremely high density. And so when you have these things combined with the flattening of the network, having the radios, and then a network architecture where the data may go directly between devices or go to the mobile edge and the devices versus all the way to the cloud and back, you have a way of increasing capacity. At the edge, the capacity is going to be much higher than at the core.
Right, and that's quite important, and it also triggers another change, which is more towards moving a lot of the infrastructure indoors, where most of the users, I say, are. And so it's a very different way to build the infrastructure and virtualize it as well. Right.
Yes. Actually, you hit on a very good point. Most of the traffic consumptions is indoor, right? And so again, I talked a little bit about licensed and unlicensed and all. And as you know, there's quite a bit of footprint on Wi-Fi. And then there's also efforts such as licensed assisted access and all that the LTE community is having in 3GPP that we will evolve into other assisted forms in 5G. And so when you have so much indoors, I think it also provides for some more controlled applications where you can have a combination of licensed technologies and unlicensed technologies. We talked a little bit while ago around mission critical or the types of data. So for example, in a factory automation, I could use licensed technologies that are more reliable for more mission critical operations, whereas I can have maybe some more unlicensed areas to augment that on like data inventory or spreadsheets or things that may not be as mission critical from a latency point of view.
Right, and you mentioned Wi-Fi, and that's it's very interesting and hot topic as well, because we moved to 5G, and Wi-Fi is also evolving to meet basically the same requirements. And so you hear two arguments at the same time. There's an argument that says, well, since you have Wi-Fi, you don't need much else because that meets all the requirements. And on the other hand, you have people that say, well, since you have 5G, you're not going to need Wi-Fi anymore. What's your view on that?
I think the truth is in the middle, and it depends on the applications. My view is both will exist. Here's why. At the end of the day, I think today's traffic, I forget the source, but from different sources, most of the traffic today is over Wi-Fi.
Yeah.
The data. So it's entrenched. Like when you go to a hotel or when you go home, you have Wi-Fi. It's very difficult to displace an entrenched ecosystem. Right. And it has a lot of users, especially consumers, right? Cameras, we all connect our devices on Wi-Fi. On the other hand, if you look at a cellular-based technology, there tends to be a quality of service or reliability that you have for licensed spectrum. Now, what is happening is the licensed spectrum is starting to offload into unlicensed areas. So for example, as I mentioned, you have licensed assisted access. But if you look at it, both of these are starting to increase. You have more LTE. We don't have enough spectrum, so we're doing 5G. And with the evolution of Wi-Fi into 802.11ax, we have more Wi-Fi installs, more Wi-Fi deployments. So what I look at it is, I think at the end of the day, every enterprise is going to have to look at how much do they want unlicensed, and do they want it more in a way they manage it, or do they want to work with a service provider such as AT&T or Verizon in the US, and then how do they get their services from them, and how do they offload to unlicensed. So I truly believe there's room for both, and depending on the use cases, you will be predominantly focusing on one or another.
Yeah, now what about using LTE and then eventually 5G for unlicensed? So LAA and the continuation of LAA when you get to 5G. So you can have cellular technologies in unlicensed bands.
Correct. So I think LAA has started it, and I think with one of the things in unlicensed is, with LAA, it follows the same coexistence protocol as Wi-Fi, which is listen before talk. And so what happens is that with LAA, it provides entities that use LTE to have access to the unlicensed area. If you look at multi-fire, actually, that's where you can be completely without an anchor in LTE, right? So the whole multi-fire technology is completely unlicensed. So to answer your question, I think that there will be growth in these areas, but if you look at the Wi-Fi area too, right, it has an entrenched ecosystem. So the real question becomes, if you look at multi-fire and its evolution, how much will that take off compared to the two ecosystems that already exist, which is around Wi-Fi and its evolution, and unlicensed that has an anchor in licensed, where a service provider operates it. So where I'm distilling this is, it's like, where do you get the service from? If you get it from an operator, it tends to have a access or a control plane that is anchored in licensed with unlicensed for augmentation. But if you go look at like independent mom and pop entities, or if you look at service providers and all, that you can have Wi-Fi, or that's also where multi-fire is trying to approach.
Yeah. Now, in the enterprise, there's a lot of interest now with the CBRS and the 3.5 gigahertz band in the US so far, but other countries eventually in different regulatory frameworks. What do you think about CBRS? How attractive it is to the enterprise?
I actually think time will tell, because from the it's quite a bit of spectrum, like about 150 megahertz, and so time will tell, because right now we are having this 3-tiered system in the US, and if it works out, it provides an alternative area where we're having a hybrid mechanism towards how do we solve these problems. But as of today, we have the utilization of it has not been completely fulfilled, right? And so, as with any new technology, right, including LAA, or even if you look at the history of Wi-Fi, it took a long time for it to evolve. And so I would say we are in the early days of CBRS. Remember back in the day, Wi-Fi used to be seen by traditional service providers as there's no need for unlicensed. And then when they ran out of spectrum, they had to do the thing so that they're very much in the middle of unlicensed. So as we start solving these barriers, we have to get over the notion of sharing a spectrum and then start to utilize it. So I think it's a question of time and the use cases that will drive it.
Right. No, absolutely. You mentioned that depending on who is providing the solution, you might use different technologies, and this I think it's a very important topic right now, is to see how the relationship between the enterprise and mobile operators is evolving. It has been so far rather a difficult relationship, but I think that both ends are now more willing and need more to work with each other. What do you think?
You said it very nicely. The real question is, if we explore why is it difficult? And while you say enterprise, if you look at 5G, right? you really are talking beyond phones and tablets. We're talking about whether it's CPEs or cars or factories and automation. The reason for the difficult relationship is I think it's two worlds that may not fully have lived on the other side, right? And so what happens is it's a question of control, right? Do the solutions that, if you look at even LTE, we had so many different variants, including Cat 1, Cat 0, Cat minus, NB-IoT, before we started getting into the right ballpark that was needed for IoT kind of devices. So the reason for the two ecosystems to start to figure out solutions is for both sides to understand each other. And I think the ones that will eventually win are the ones that know how to transform into services. So the more the traditional cellular service providers know how do they transform from a voice-centered to a data center to a services-oriented company that is more affordable and solves the needs of the enterprise, the faster that coalition will happen. Otherwise, from an enterprise point of view, that's what drives the enterprise to look at solutions that are maybe more in unlicensed or other areas, is because they don't want to necessarily have to rely on a traditional service provider and the fees over there. So it's a transformation that needs to solve the pain points of the enterprise.
And who is going to pay for the infrastructure when there is the mobile wireless network that it's not a Wi-Fi, but a wireless network, cellular network that goes into the enterprise? Who you think is going to pay at the end? Is it the mobile operators or the enterprise, or both?
Or both, or there could even be a third option. So let me give an example, right? One of my favorite quotes is that technology is predictable, human behavior is not, right? And so if you look at every evolution, 5-6 years in the middle of it, we completely changed what we built it for. 3G was built to replace 2G and voice, but then when the smartphones came out, it completely changed what we did. And there's an app for that happened, right? And then in 4G, there was this whole thing that was built ahead of its time called IMS, and we don't use much of IMS because the OTT guys took over when we unleashed those capabilities. And so you have, and even 10 years ago, right? I don't know that we would be having a conversation where Airbnb or Uber and all would be some of the biggest providers in their categories. We would think that taxi unions would be there for another 1,000 years, right? So these evolutions happen very quickly. And cost is a very interesting thing. Now, if I have a very high density of cost and costs go electrical, for example, right? Sorry, cars go electrical. So why wouldn't I, for example, have an electricity provider maybe lease some of these, just like you can look at leasing on the spectrum, right? So it could be the mobile operator that provides the service in some certain geos. It could be the service consumption because they don't want to share it. But there could be a third one, especially as we start, depending on how much we get regulated and all, like an electricity provider, right? That can build these small cells on the bridges, or something that they can lease to either a service provider, or they can work with maybe, car manufacturer on.
Yeah. So yeah, and I guess it's difficult to predict because some might work, or some might work in some areas, but not in others. Or some environments.
In different countries.
In different countries. So and I guess that's really the greatest thing, since, as you said, humans are less predictable than technology. If technology allows you to do more, then the humans can do more, for better or worse. But there is more of an opportunity to see innovation there. Now, one thing that we only briefly touched upon is security, and security is becoming more, has always been obviously an issue, but becomes even more of an issue as wireless communications become mission critical in the enterprise. How does the enterprise deal with the security issues that are to some extent new to them when you get more and more networks, more and more interfaces, more services, then security becomes even more complex?
Yes, security, I think, will become like the core of what enables things. And it's at multiple levels, right? There's hardware security, there's security in the policies we use, what data we can transmit. And related to security, as important is privacy, right? And so the two go hand in hand. And I think this is a problem that has to be solved at multiple levels. It has to be solved by the enterprise knowing what risks it wants to take, by the service providing knowing how to protect the data, having the controls in place to make sure that maybe the data doesn't leave the enterprise, as an example, for if that's one of the policy requirements, the policies we have. And we can do something such as metadata and all that protects the individual users. From an Intel point of view, we had the investment in terms of McAfee, right? That we still have a hand in, but also we also look at our hardware platforms and software platforms with hooks around security that we continue to evolve in. So it is one of those things. And as security becomes more important, I think we as enterprise users or enterprise owners will have to start paying for it. And once we pay for it, we can tune to what are our degrees of degrees of freedom, and we have to solve it like an onion in different layers.
Yeah. So I guess it's part of a different a new strategy that you need to look into in more detail and put a little bit more effort into it than we traditionally have. Asha, well, it was great talking to you. It was very, very interesting interview, and thanks for sharing your insights with us today.
Thank you very much, and my pleasure again, and good chatting with you. So till next time.
Okay, and this was a conversation. It's part of a report on the evolution of wireless connectivity in the enterprise by Senza Fili in collaboration with RCR Wireless. Thank you all for listening in.
Thank you.